Here's a trigonometric example that involves the quotient rule. We have f of x is equal to the sine of x divided by cosine of x. So we'll apply our quotient rule. F prime of x is equal to the derivative of the numerator times the denominator minus the derivative of the denominator times the numerator. And that's all going to be divided by the denominator squared. So the derivative of sine is cosine. So we end up with a cosine of x times a cosine of x. We're going to subtract. The derivative of cosine is negative sine. And we're going to multiply that by sine of x. That's all over the cosine of x squared. So if we take care of this minus of a negative in the middle here, we're going to end up with cosine squared plus sine squared of x, all divided by cosine squared of x. And that's the same thing as 1 divided by the cosine squared of x. Cosine squared plus sine squared, that's a Pythagorean identity, that's equal to 1. So the top becomes 1, bottom still cosine squared, and we can rewrite that as the secant squared of x. Now, if you'll notice, sine of x over cosine of x is tangent of x. So we've just found a derivative for a new trig function. You can go through the same process for cotangent, for secant, and for cosecant, and you will eventually develop the following rules. So we now know that the derivative with respect to x of sine of x is equal to cosine of x, and the derivative with respect to x of cosine of x is negative sine of x. You've just seen the derivative with respect to x of tangent of x is equal to secant squared of x. Similarly, the derivative with respect to x of cotangent of x is equal to negative cosecant squared of x. The derivative with respect to x of the secant of x, it turns out, is the secant of x times the tangent of x. And the derivative with respect to x of the cosecant of x is equal to the negative cosecant x cotangent x. Now you have rules for all 6 of our basic trig functions, and these are rules that you should commit to memory. They will arise from time to time. You will see them on things like tests. You'll see them as parts of other problems. And it'll be useful if you just know them as opposed to having to go through a quotient rule process to try to rederive them every time. They do show up often enough that it is useful for you to have them memorized.